Alright guys, welcome back. Hopefully you did good on 8.1. Just FYI, if you're struggling as far as with a particular question anywhere in this book, the majority of the answers I can actually be found online. And I don't tell you that so that you go cheat or anything like that, but if you really get stuck on a question, maybe that's not covered in one of my videos or not covered in somebody else's video, I do encourage you to look that up. The majority of the stuff could be found, again, just to kind of help you with that, all right? So we're going to 8.2. We're going to be on page 92. And now we're going to be looking at writing equations of parallel and perpendicular lines. And so before we do that, we really need to cover some basic algebra stuff that should have been covered in Algebra 1, but who knows if you remember it right. So let's just cover it just to make sure we're good. So first things first, we have three equations that we use generally when we're talking about linear equations, when we're talking about the equations of a line. The most common one is going to be slope-intercept form of a line. That is the y equals mx plus b, okay, where the m stands for the slope and the b stands for the y-intercept. That's probably the most common. That's where you can put a dot on the y-intercept and then simply count out the slope and draw the line. So if we were to have, let's say, y equals 2 over 3x plus 1, right? And I wanted to graph that. All I would do is I would go up to 1 on the y-axis, put a dot, and then I would count up 2 and over 3, put a dot, and then connect those dots and voila. Probably my favorite, probably the most common to use is slope-intercept. And so it's y equals mx plus b. Again, the m is the slope and the b is the y-intercept. Another form, which I know there's kind of a glare right here, but this has point slope form of a line, and that is y minus y1 equals m x minus x1. Point slope is really nice if you're given a problem and they want you to find the equation for a line, and you're having to start with maybe just given 2 points or starting from scratch. This one's a little easier to do because you don't actually have to know where it crosses the y-intercept. All you have to know is you have to be able to find the slope, which we talked about last activity, and we're going to do again here in a minute. And then you have to just have a point, and that's not too hard, right? So point slope form, maybe you're given a point, let's say 3, 2, and you're told the slope is, let's say m equals 1/2, yeah? Then at that point, all you would do is plug those values in. Keep in mind the 3, the first number is going to be the x value, so that's going to be x1. The 2 is y1. And so you're simply going to plug that in. I'm going to write y, and then minus 2. Notice it's a minus y1, so it would be a minus 2 equals, now I'm just going to write my slope 1/2, parentheses, x, and then notice this is a minus x1, so this 3 here is going to be a minus 3, okay? Now if you wanted to convert that into slope-intercept form, what you would do is distribute the half, so you would get 1/2 x minus 3/2, and then you would add 2 to both sides. So basically you would solve for y. You would distribute the half and then move the 2 over and you would turn it into slope-intercept, okay? So hopefully that makes sense. The last one, the one I have up here at the top, is the standard form of a line. We don't use it very much, at least not for this course, but it's very nice because it's very easy to find the x and y intercepts. You can simply plug in a 0 for x, and then you get c over b is going to be the y value that pops up, and then you're going to get plug in 0 for y, and then c over a is the x value that pops up, and it allows you to graph using the intercepts very quickly. The magic being that a, b, and c are all whole numbers. So you would have to multiply whatever you need to multiply by in order to make those whole numbers. So you couldn't have a half, you would have to multiply everything by 2, something like that, okay? So that's standard form. We don't do as much with that, but standard form is going to be if you see whole numbers, that's what you're looking at, all right? And there are some patterns there, but again, that's Algebra 1. We're not going to focus too much on it. One more real quick Algebra 1 reminder. I wanted to remind you how to find the equation of a line given 2 points, okay? I've kind of boiled it down to a very simple process. Basically, you're going to find the slope, right? Remember that slope formula? Don't remember the slope formula? So it's what? M equals y2 minus y1 over x2 minus x1, yeah? So you're going to find the slope. You simply take the 2 values they gave you and you find the slope. Once you have that slope, you're going to take one of those points and the slope, and you're going to plug it into the point slope form, okay? And then if the question wants you to do slope-intercept, then you would solve for y and change it into slope-intercept, okay? So again, not a super complicated process there. So let's do an example. I have one up here. I have a is at 2, 3, and b is at -1, -3. And so I want to find the equation of that line. And so I'm going to say find equation. All right, so what was my first step? Find slope, right? So first step, find slope. And so I'm going to write my formula. Because remember, maybe I don't have it down cold yet, so I'm going to go ahead and copy it down, y2 minus y1 over x2 minus x1. And then I'm going to substitute. And a lot of times for me, just to make sure I keep it safe, if I have my 2 points here, I'll write like x1, y1 on the top one, and x2, y2 on the bottom one. Doesn't matter. It really doesn't. If you do it one way, you'll end up with more negatives than the other, but it's all going to come out to the same value in the end. Negative divided by negative would still be a positive answer, and vice versa. Okay? So I'm going to plug in the values I have. So my y2 here, I have a -3, so this is -3. And then my y1 is 3, so -3, because remember it's y2 minus y1. x2 is -1, and x1 is 2, so -2. All right? -3 minus 3 is not 0. Be careful here. Think about it on a number line. If here's your 0, 1, 2, -3, if I go negative, I'm going this way. So it's a bigger negative. You add them together, you're going to get -6 over -1 minus 2 is -3. Negative over negative becomes a positive, and 6 divided by 3 is just 2. So my slope here is actually 2. I'm going to write it as 2 over 1, just so you can see that it is still technically a fraction, but really my slope is 2, and I'm going to put that equals m just to remind myself that that's my slope and that m is my slope. Okay, so that was my first step. Second step, you know what the second step is? That's right, we plug it in the point slope formula. So here's my point slope formula. Y minus y1 equals m x minus x1. So again, I'm still practicing with my formulas. I'm going to write that. Y minus y1 equals m x minus x1. Okay. Then I'm going to substitute. What am I going to substitute? Well, here's my m. So there's going to be a 2 there. And then here's my values I'm going to use for my x1 and y1. So I'm going to have y minus, y1 happens to be 3. And then my slope is 2. And then x minus 2. Okay, everybody kind of following along with that, hopefully? Now, just for practice sakes, I'm going to go ahead and turn this into slope-intercept form. So I'm going to go ahead and distribute my 2. So I'm going to get 2x minus 4. And then I'm going to add 3 to both sides. Now over here, my positive 3 and my negative 3 are going to cancel. Over here, I've got a -4 and a +3. -4 plus 3 or 3 minus 4. Either way, I'm going to get a -1. I've still got my 2x. And I'm just going to bring down my y. All right? So think about it. Y equals 2x minus 1. What am I going to get? I'm going to get a line that crosses at -1, has a slope of 2. So I'm going to go up 1, 2, over 1, put a dot. There's my line. And you could check it. Both of these points would be on this line. Okay? Both of those points would be on that line, but there's my line. Now, let's talk about what we're doing in this section. In this section, we're going to be asked to find lines that are parallel or perpendicular and their equations. So, let's do both. Okay, we're going to use this. This is going to be our standard example, and we're going to take this line. We're going to take line AB, and we're going to find both. The first thing we're going to do is we're going to talk about a line parallel to AB. How do we know it's parallel to AB? What does it mean to be parallel? Do y'all remember? Parallel means same slope, right? So if I'm looking at an equation, I need one with the same slope. So let's do 2 lines on here. Let's say I had y equals 2x minus 7 and y equals -2x minus 1, right? Which one is parallel? Well, the one with the same slope. This one might have the same intercept, but it's not this one. This one is parallel. Okay? Because it has the same slope, because of that value right there, because the m value is the same. All right? Now, what the book's going to do is, yeah, it might ask you to identify, hey, which one's parallel, but really we want to go beyond that because we're writing equations here, okay? So we're going to go a step further. I'm going to say I want one that's parallel to this line, but goes through, well, let's do 7, 8, right? So let's say we want a line that goes through C. C is going to be at 7, 8. And I want a line that is parallel to AB, so parallel to AB, and it goes through C, so through C. How do I do that? Well, I already know my slope, right? So my slope is going to have to be 2, right? Because it's parallel, the slope has to be the same. And then I have my point. That's where this point slope form is so powerful, because there's almost no work to do. Really, all I'm going to do is list, okay, well, this is going to be my x1, this is my y1, and I'm going to literally write my answer. Y minus y1, oh, y1's 8, y minus 8 equals slope, m, so 2, parentheses, x minus x1. Wait, x1 is 7. Done. There's my equation, okay? Maybe you have to carry it a step further to turn it into slope-intercept form, and that's okay, we can do that. We distribute the 2, we get negative 14, and then we're going to add 8. And we're in geometry, not algebra, so I'm not going to show every single step. So, again, negative 14 plus 8, that gives us a negative 6, so 2x minus 6. There you go. There's the equation of a line parallel to AB, parallel to this line, that goes to the point 7, 8. Okay? Now, what would it look like on our graph? Well, it has an intercept of negative 6, so 1, 2, 3, 4, 5 further down, looks something like that. And it's parallel. Notice they wouldn't cross. Okay? So that's parallel. What about perpendicular? Well, certainly perpendicular is a lot harder. Not really. Okay? If you can remember that your slope is a fraction, if you can remember that 2 is really 2 over 1, then you can do perpendicular almost as easy. Alright? Forgive me, I'm going to go ahead and erase the parallel part. If you need to see it again, you can always pause the video or back up. So we're going to erase this little parallel part. And we're going to talk about perpendicular. What is perpendicular? Perpendicular is a negative reciprocal slope. Okay? So perpendicular means that our slope is going to be flipped fraction, change the sign, yeah? So if our original fraction is 2, that's not a fraction, I'm sure it is, it's 2 over 1. If our original slope is 2 over 1, our perpendicular slope is going to be 1 over 2, but we're going to make it negative, so negative 1/2. So if I wanted a perpendicular line, do you know what the symbol for perpendicular? Perpendicular is you draw like an upside down T. So we want perpendicular to AB, okay, and we're going to say through, and let's pick a really ugly number, yeah, let's go with negatives and big numbers. Let's go with like negative 11, comma, I don't know, 17, right? Kind of ugly, but that's the magic. It doesn't actually matter. It doesn't make it any harder. We can automatically, that's my word by the way, automatically, we can automatically find the slope, right? If our original slope was 2 over 1, we're going to flip that to 1 over 2, and we're going to make it negative. This is going to be my slope of a perpendicular line. Okay? So my m is negative 1/2. And that's all I need. Remember? Point slope? I can simply plug it in. So I'm going to write it over here because I got a little more space here. I'm going to write y minus y1 equals m x minus x1, and then I'm going to use these. Remember, this is my x1, this is my y1, so y minus 17 equals negative 1 over 2 x, put our parentheses in there, minus 11. Minus, that, I don't, what? No, I write both just to remind myself to be careful. I know that a negative times a negative is going to turn into a positive. I know this is going to be x plus 11, but I write the minus just to check myself, to make sure I don't miss something. And now I'm going to rewrite this. So I'm going to rewrite this as y minus 17 equals 1/2 x plus 11. Okay? If we want it in slope-intercept form, same process. What's half of 11? 5.5. Everybody okay with that? Half of 11 divided by 2 would be 5.5. So this is 5.5, this is a minus 17. I would add 17 to 5.5. So 17 plus 5.5, so I would get y equals, this is still a negative, negative 1/2 x. Ooh, bad teacher. Time, rewind, hold on, what happened? Why is he saying bad teacher? Notice my negative 1/2 here? Yeah, this becomes a positive 11. But positive 11 times negative 1/2 is not 5.5, it's negative 5.5, okay? So when I add 17 to both sides, it's not going to be 17 plus 5.5. It's going to be 17 minus 5.5, okay? So in reality here, what I'm looking at is negative 1/2 x plus 17 minus 5.5, or 11 over 2, okay? And 17 minus 5.5, I'm going to go ahead and clean that up a little bit. So I have negative 1/2 x. 17 minus 5 is 12, minus another half is 11.5, so plus 11.5. We'll put equals y over here. So there is our equation. There's our slope-intercept equation of a line that is perpendicular to AB and through negative 11, 17. Okay? I picked funky numbers because I wanted you to realize it doesn't matter what numbers you pick. All right? So, in the book, what are we looking at now? Well, we kind of talked through 1 through 5. All right? We kind of talked through what's happening in that picture and talked through the idea there. You can go ahead and read page 92. But really, the work is going to start on page 93. I want you to do number 6, okay? Number 6 is going to practice doing what we just did. Use this board. I'll let you get a good picture of it. You can freeze the video right there if you need to or come back to it. But use this as an example to do number 6. Let's say 4 minutes, 4 or 5 minutes, real quick, okay? And then come back to me and we're going to talk about the next section.